Hello everyone. We'll continue our problems on Francis turbine. Already we have solved three problems. In this session, I'm going to solve problems from the question paper or from K. Subramaniam book. Okay, just to revise what we have to know as far as Francis turbine is concerned. So here, if you look at general features of Francis turbine, the speed factor Ku or phi is given by U by root 2 GH, or U is given by Ku into root 2 GH. That's again written here. Then flow ratio psi is equal to Vf1 divided by root 2 GH. Same equation is written here. We are going to use this yellow panel often. Then this we have been hearing, generally velocity of the whirl or swirl velocity at the outlet is kept 0, that is Vw2 is kept 0. So in this outlet velocity triangle, this has to be 0 in the sense this V2 has to go this way, that is to say the angle beta has to be 90 degrees. Most of the time it is given. If it is not given, one can assume that. Then the discharge is given by that cylindrical surface area pi dB multiplied by velocity of flow. This is at the entrance, this is at the exit. The torque is given by rho AV or rho Q in the bracket Vw1 plus or minus Vw2 R2. If this becomes 0, the expression becomes rho Q Vw1 R1. Similarly here power T into omega, similar kind of expression rho Q Vw1 U1 plus or minus Vw2 U2. Hydraulic efficiency, this becomes Vw1 U1 by GH if this is becoming 0. That is what has to be remembered. So here is a problem 16.5 from K. Subramaniam. If you look at the things asked and data given, alpha, that is angle of the jet at the inlet, is asked, power developed is so much, Q is given, RPM is 200, inlet diameter is given, inlet width of the flow is given, beta, that is angle made by the jet when it goes outside, is given to be 0 because they have said it leaves the runner radially. As discussed, this is most often data. Then they have said blade angle at the outlet is obtuse, so theta has to be obtuse. Now if you look at our inlet velocity triangle, general inlet velocity triangle, U, the V, this is VR, this is blade angle or jet angle, this is set angle or guide vane angle, this is vane angle at the inlet. Now they have said this has to be obtuse, so the inlet velocity triangle will not be like this. This has to be obtuse in the sense this has to go more than 90. Okay. This is how the triangle will be. You can see here the angle is made more than 90. So this is VR1, this is V, this is U. Now component of velocity here, this is Vw1, and this vertical component is Vf1. Now starting with this equation U equal to pi dn by 60, we'll be able to get U because all other data is given, 31.42. P, because VW2 is given to be 0, rho Q into bracket VW1 U1, P is given, rho Q is given, VW1 U1 already calculated. So VW1 becomes 8.487. That's over here. Q is equal to pi dp Vf1. So from this Vf1 also will be able to get. Vf1 will be able to get. So we know this. We know this much. Also we know this whole thing. Because of that, I'll be able to calculate alpha as well as theta dashed. So tan alpha, if I write, it will be opposite side upon adjacent side. Alpha is calculated. If I want to calculate theta dashed, this is opposite side, that is 3.537 divided by this. This is the difference of these two. So theta dashed is calculated, inter theta is calculated. So one more problem, 16.6. Again, if you read the problem, RPM is given, head is given, D1 is given. So D1, P1, this should have been lowercase letters because flow area is given. Flow area is pi dB. Actually, this should have been pi dB is 0.4 meter square. Alpha is given, theta is given, P is asked, hydraulic efficiency is asked, VW2 is 0. That is, assume that the velocity of whirl at the outlet is 0. Okay, that is the data. And if we draw a velocity triangle in a usual manner, it will be like this. U equal to pi d n by 60. The data of t1 and n is given, so I'll be able to get this 28.27. Then pi dp into Vf1, pi is missing here, pi dp Vf1 equal to q. So here the q becomes 5.211. To check the calculations, P is given by this. From this, VW2 is 0. P can be calculated. Hydraulic efficiency is VW1 U1 by GH. Right? How to get VW1 from the triangle? We'll see here. This is already calculated. This angle becomes 120 because it is 60. This is given 13.03. This angle is given, because of that this VR1 is calculated, and by sine rule I'll be able to get both V1 and VR1, which will be made use of over here.